1942, the Eastern Front. Soviet Union, the Siege of Sevastopol. The Germans have surrounded the city. The Germans have deployed enormous forces, but the city is heavily fortified. The Soviets have built concrete bunkers. The Soviets have dug trenches. The Soviets have fortified the position with years of preparation. The German assault is slow. The German casualties are high. The German forces cannot break through the Soviet defenses. German command needs something extraordinary. German command needs something never before attempted. German command needs the greatest gun ever built. Then, a sound unlike anything heard before in warfare. The rumble of enormous machinery moving on railroad tracks. The Schwerer Gustav, the Heavy Gustav, the greatest gun ever built. This gun is 47 meters long when positioned for firing. This gun weighs 350 tons. This gun fires an 800mm shell. That is a projectile nearly 2.5 feet in diameter. A projectile that weighs 7 tons. This gun can fire a projectile 47 kilometers away. That is nearly 30 miles. The shell travels at speeds exceeding 2,600 feet per second. The impact force is beyond comprehension. When the Schwerer Gustav fires, the explosion is visible for miles. When the Schwerer Gustav fires, the shockwave can be felt miles away. When the Schwerer Gustav fires, a target is obliterated. The gun is so powerful that it can penetrate concrete bunkers. The gun is so powerful that it can destroy fortified positions that conventional artillery cannot touch. The gun is so powerful that it represents the ultimate expression of artillery science. But there is a mystery. If this gun is so powerful, if this gun can destroy fortified positions, if this gun represents the pinnacle of German engineering, why did this gun not change the course of the war? Why did this gun not turn German defeat into German victory? Why did the greatest gun ever built not achieve the greatest results? This is the story of the Schwerer Gustav, the greatest gun ever built, but also a cautionary tale about engineering excess. A tale about the difference between technological achievement and military effectiveness. A tale about how the most impressive weapon can have the least impressive impact. To comprehend the Schwerer Gustav, one must understand the context of German military development during the 1930s and early 1940s. Beginning in 1933, Germany underwent massive rearmament. The German army built tanks. The German army built aircraft. The German army built warships. The German military was being transformed into the most powerful fighting force in Europe. But there was a problem. The Soviet Union was also rearming. The Soviet Union was building fortifications. The Soviet Union was constructing defensive positions along its borders. The Soviet Union was preparing for invasion. German military planners examined the Soviet defenses. German planners realized that conventional artillery could not penetrate the strongest Soviet fortifications. German planners believed that Germany would eventually invade the Soviet Union. German planners believed that defeating the Soviet fortifications would be extraordinarily difficult. In the mid-1930s, German military command issued a specification. Build an artillery gun that can penetrate the strongest Soviet concrete fortifications. The gun must be capable of destroying bunkers that no conventional artillery could touch. The gun must be the most powerful artillery piece ever built. German industry, led by the Krupp Steelworks, accepted the challenge. Krupp was Germany's premier steel and armaments manufacturer. Krupp had the resources. Krupp had the expertise. Krupp had the capability. Krupp engineers began designing. The engineers examined the problem. How to build a gun that can fire an 800mm shell over long distances with sufficient penetrating power to destroy the strongest fortifications. The design took years. The gun had to be extraordinarily strong to withstand the internal pressures. The gun had to be enormously long to achieve the velocity and range needed. The gun had to be extraordinarily heavy to achieve the structural integrity needed. By the late 1930s, Krupp had a design. The gun would be a railway gun. The gun would be mounted on specially designed railway cars. The gun would be too large to be mobile except on rails. The gun would travel on railroad tracks to its firing position. Construction began in 1936. The gun took years to build. The metalwork was extraordinarily complex. The assembly was extraordinarily difficult. The engineering required was unprecedented. By 1941, the first gun, named Gustav, was complete. The gun was tested. The gun performed beyond expectations. The gun was even more powerful than anticipated. German command was impressed. The specifications were extraordinary. 800mm caliber, 31.5 inches. 47 meters long when positioned for firing, 155 feet. 350 tons total weight, range of 47 kilometers, 29 miles. Shell weight of 7 tons. A second gun, named Dora, was constructed to the same specifications. Both guns entered German service in 1942. The guns were assigned to be deployed against Soviet fortifications. The war with the Soviet Union had begun in June 1941. The German forces were fighting Soviet forces across Eastern Europe. The guns were intended to break through the strongest Soviet defensive positions. In June 1942, the Gustav gun was assigned to the Siege of Sevastopol. Sevastopol was a major Soviet naval base. Sevastopol was heavily fortified. Sevastopol had concrete bunkers and defensive positions. The German assault was slow and costly. The Gustav gun was positioned. It took days to move the gun into position. It took days to set up the gun for firing. It took days to prepare ammunition. Finally, the gun was ready. The Schwerer Gustav was about to fire in combat for the first time. This moment would demonstrate whether the most powerful gun ever built could achieve the strategic impact that justified its existence. The first anomaly emerges from the fundamental contradiction of the Schwerer Gustav. The gun is extraordinarily powerful, but the gun's mobility is extraordinarily limited. A railway gun can only travel on railroad tracks. The Schwerer Gustav requires specially prepared tracks. The Schwerer Gustav cannot deviate from those tracks. The Schwerer Gustav cannot move to new positions quickly. Positioning the gun for a new target requires 1. Specially built or prepared railway line. 2. The tracks must reach the new firing position. 3. The gun must be slowly moved by locomotive. 4. The movement is visible and can be observed. 5. Enemy forces can prepare defenses. 6. Enemy forces can position countermeasures. In modern warfare, mobility is crucial. An air superiority enemy can attack a stationary gun. An air superiority enemy can attack a gun in movement. A mobile gun can reposition to avoid attack. The Schwerer Gustav cannot reposition quickly. The second anomaly, the ammunition consumption versus ammunition supply. The gun fires one shell approximately every 30 minutes. Theoretical rate of fire. Each shell weighs 7 tons. Each shell costs approximately 1 million Reichsmarks. The supply of shells is limited. At Sevastopol, the gun fired approximately 30-50 rounds total. The gun was in operation for several weeks, but the total number of rounds fired was modest. Why ammunition was expensive? Ammunition was difficult to transport. The production of 800mm ammunition was slow. The third anomaly, the crew requirements. The gun requires approximately 250 personnel to operate. That is the entire complement of a warship. That is a substantial military unit, all to fire one gun. The crew includes ammunition handlers, 50+ personnel, mechanics and technicians, 30+ personnel, power generation crew, 10+ personnel, loading and firing crew, 20+ personnel, security forces, 50+ personnel, support personnel, 50+ personnel, command staff, 10+ personnel. For a single gun, this represents an enormous commitment of personnel. In modern warfare, manpower is precious. Assigning 250 personnel to operate one gun means 250 personnel cannot be used for other operations. 250 personnel cannot garrison defensive positions. 250 personnel cannot reinforce other combat units. The fourth anomaly, the support infrastructure. The gun does not operate in isolation. The gun requires ammunition train, separate from the gun, diesel generators for power, repair facilities, medical facilities, barracks and quarters for crew, food and supply lines, transportation for personnel, anti-aircraft defenses, infantry protection. All of this support infrastructure is stationary or slow-moving. All of this support infrastructure is visible to enemy forces. All of this support infrastructure is vulnerable to air attack. The fifth anomaly, the cost-benefit analysis. Each round fired costs approximately 1 million Reichsmarks. The ammunition cost alone is extraordinary. The manufacturing cost of the gun was 75 million Reichsmarks. The total cost of the program, including Dora, exceeded 150 million Reichsmarks. For comparison, a modern fighter aircraft costs less, in equivalent 1942 terms. A modern tank production program costs less. A modern destroyer costs less. The Schwerer Gustav program consumed resources that could have built 100 tanks or built a dozen fighter aircraft. The sixth anomaly, the tactical impact. Despite being the most powerful gun ever built, the Schwerer Gustav's tactical impact was modest. At Sevastopol, the gun destroyed Soviet fortifications, but the Soviet fortifications were rebuilt or bypassed. The gun did not break the siege. The siege was broken by conventional infantry assault after weeks of fighting. The gun was effective at destroying individual targets, but the gun could not achieve strategic breakthrough. The gun could not end the battle quickly. The gun could not transform the tactical situation. These anomalies accumulate: limited mobility, expensive ammunition, enormous crew, extensive support infrastructure, astronomical cost, limited tactical impact. These anomalies suggest that the Schwerer Gustav was not the war-winning weapon it was designed to be. These anomalies suggest that power alone does not determine military effectiveness. These anomalies raise fundamental questions about German weapons development. What went wrong with the superweapon? Why did the greatest gun ever built not achieve the greatest results? Examining why the Schwerer Gustav failed to achieve strategic impact requires analyzing the weapon's actual operational performance versus its design intentions. The Schwerer Gustav was designed to penetrate the strongest Soviet fortifications. The gun achieved this objective. The gun's shells could penetrate concrete bunkers that conventional artillery could not touch. The gun demonstrated penetrating power beyond anything previously achieved. However, penetrating fortifications and breaking a siege are two different things. A fortress can be heavily damaged and still be held. A bunker can be penetrated and the garrison can withdraw. A defensive position can be destroyed, and the defenders can establish new positions. The gun achieved local tactical success. The gun did not achieve strategic breakthrough. The fundamental limitation of the Schwerer Gustav was its immobility. By 1942, air superiority was becoming increasingly important. The Luftwaffe was losing air superiority to Soviet forces. The Luftwaffe was losing control of the skies. The Schwerer Gustav could be attacked from the air while stationary. The Schwerer Gustav could be attacked from the air while moving on rails. The Schwerer Gustav could not reposition quickly to avoid attack. Once the gun's position became known, it became a target. Once enemy forces identified the railway line supporting the gun, they could attack the line. An air attack on a stationary gun was comparatively easy. An air attack on a railway gun in movement was feasible. Defense against air attack required fighter aircraft protection. The Luftwaffe could not spare sufficient fighters to protect the gun continuously. The gun required 7-ton shells. These shells required specific machinery to manufacture. The production rate was slow. The supply was never adequate to the gun's potential firing rate. If the gun fired at maximum theoretical rate, 1 round every 30 minutes, ammunition would be expended quickly. But ammunition supply was limited. Ammunition transport required special rail cars. Ammunition transport was slow and visible. The ammunition supply problem meant the gun could not fire continuously. The gun could fire sporadic rounds against carefully chosen targets. But sustained bombardment was impossible due to ammunition shortage. Operating the Schwerer Gustav required 250 personnel. This number seems excessive for a single weapon, but the number was necessary. Loading shells of 7 tons required mechanical assistance. Mechanical assistance required operators. Targeting the gun from 47 kilometers away required specialized equipment. Recoil absorption required hydraulic systems. Hydraulic systems required maintenance personnel. Ammunition transport required handlers. Security required infantry. However, concentrating 250 personnel in one location created a vulnerability. A successful air attack would kill multiple crew members. Disruption of one system, ammunition transport, power generation, would disable the entire gun. The concentration of personnel made the gun a lucrative target. The Schwerer Gustav program cost approximately 75 million Reichsmarks per gun. Total cost for both guns, 150 million Reichsmarks. Each round cost approximately 1 million Reichsmarks. At Sevastopol, approximately 30-50 rounds were fired. Total ammunition cost, 30-50 million Reichsmarks. Total program cost, approximately 200+ million Reichsmarks. What else could Germany have purchased with 200 million Reichsmarks? Approximately 1,000 PZKW-3 tanks, at 150,000 Reichsmarks each. Approximately 500 PZKW-4 tanks, at 300,000 Reichsmarks each. Approximately 400 Messerschmitt Bf-109 fighters at 400,000 Reichsmarks each. The cost-benefit ratio of the Schwerer Gustav was poor. The gun achieved local tactical success, but the cost-benefit ratio did not justify the expenditure of resources. Deploying the Schwerer Gustav required 1. Preparing railway line, days of work. 2. Transporting gun to position, days of travel. 3. Setting up gun at firing position, days of assembly. 4. Registering gun on targets, hours to days. 5. Beginning firing operations. From initial decision to first shot could take 1 to 2 weeks. By that time, tactical situation could have changed. By that time, enemy forces could have repositioned. By that time, the gun might no longer be needed at that location. Repositioning to a new target required the entire process to be repeated. This inflexibility meant the gun could not respond to rapidly changing situations. This inflexibility limited the gun's tactical utility. The Schwerer Gustav was produced between 1936 and 1941. The guns entered service in 1942. Total combat use spanned from 1942-1945, 3 years. But the guns were not continuously in operation. The guns were deployed for specific sieges or battles. Between deployments, the guns were in maintenance or transit. Total rounds fired by both guns during entire war. Estimated 300+ rounds. Average per gun, 150 rounds total. Average per year, 50 rounds per year per gun. Average per month, 4 rounds per month per gun. This represents utilization far below design capacity. Design capacity would have supported 100+ rounds per month if ammunition were available and deployment time allowed. Actual usage was 4 rounds per month. The Schwerer Gustav was designed to be a war-winning weapon. The gun was supposed to penetrate Soviet fortifications. The gun was supposed to break through defensive lines. The gun was supposed to enable German breakthrough and victory. The actual strategic impact was minimal. The gun helped break the Siege of Sevastopol. But Sevastopol fell to conventional infantry assault, not to the gun. The gun did not prevent German defeat. The gun did not alter the trajectory of the Eastern Front. The gun did not change the course of World War II. The Schwerer Gustav investigation reveals 1. Design excellence. The gun was engineered exceptionally well, too. Performance superiority. The gun performed as designed. 3. Tactical limitation. The gun had limited tactical mobility and flexibility. 4. Strategic irrelevance. The gun could not affect the strategic situation. 5. Resource inefficiency. The gun consumed enormous resources for modest results. 6. Air vulnerability. The gun was vulnerable to air attack by 1942+. 7. Ammunition constraint. Limited ammunition supply, restricted firing. 8. Deployment limitation. Time required to deploy and reposition, limited utility. 9. Opportunity cost. Resources used for gun could have bought 1,000 tanks. 10. War outcome irrelevance. Gun could not prevent German defeat. The Schwerer Gustav was a technological marvel. The Schwerer Gustav was an engineering triumph. The Schwerer Gustav was also a strategic dead end. The gun represented resources consumed that could have been used for mobile artillery, tanks, or aircraft, all of which would have been more strategically beneficial. The gun represented engineering brilliance applied to an inflexible solution to a strategic problem that required flexibility. The Schwerer Gustav was a masterpiece of engineering. The Schwerer Gustav was a failure of strategy. However, do not dismiss the Schwerer Gustav as purely a failure. Do not conclude that the gun was a waste of resources and effort. Do not assume that the gun achieved nothing of value. Numerous military historians and engineers argue that the Schwerer Gustav deserves recognition for substantial achievements. Their arguments merit serious examination. Proponents observe that the Schwerer Gustav represented the pinnacle of 1940s artillery engineering. No gun of this caliber had ever been built before. No gun of this size had ever been successfully operated in combat. The engineering required to build the gun was unprecedented. Building an 800mm gun required solving problems that had never been solved before. How to manufacture a barrel that could withstand internal pressures exceeding previous limits. How to construct a breech mechanism strong enough to contain the explosion. How to engineer a recoil system that could absorb the energy. How to create a firing mechanism capable of igniting 800mm ammunition. Each of these problems required innovation. Each of these problems was solved successfully. Defenders contend, judging the Schwerer Gustav purely on military effectiveness ignores the engineering achievement that should be recognized independently. Advocates note that the gun achieved every specification it was designed to meet. Range, designed for 47 km, achieved 47 km. Caliber, designed for 800 meters, successfully built 800 meters. Penetration, designed to penetrate concrete bunkers, successfully penetrated bunkers. Destructive power, designed to destroy fortifications, successfully destroyed fortifications. The gun never failed due to design flaws. The gun never experienced catastrophic mechanical failure. The gun never proved inadequate to its designed purpose. The gun worked as intended every time it fired. The enemy did not overcome the gun because the gun was defective. The enemy overcame the gun because of external factors: air attack, ammunition shortage, mobility limitations. These external factors were not the gun's fault. Defenders contend a weapon should be judged on whether it performs its designed function. The Schwerer Gustav performed its function perfectly. Proponents emphasize that the Schwerer Gustav destroyed Soviet fortifications at Sevastopol that conventional artillery could not damage. German conventional artillery could not penetrate the Soviet concrete bunkers. The Soviet fortifications had been constructed for years. The Soviet bunkers were extremely strong. German conventional guns were insufficient. The Schwerer Gustav could penetrate these fortifications. The Gustav's shells could destroy bunkers that conventional artillery could not touch. This was a genuine tactical advantage. This was a genuine contribution to breaking the siege. Without the Schwerer Gustav, German forces would have needed to accept higher casualties in frontal assaults, spend more time on the siege, commit more forces to the operation, possibly fail to achieve the breakthrough. Defenders contend the Schwerer Gustav provided genuine military capability that nothing else could provide. Advocates argue that the psychological impact of the Schwerer Gustav affected Soviet decision-making. The Soviets knew the gun existed. The Soviets knew the gun was extraordinarily powerful. The Soviets knew the gun could destroy their fortifications. This knowledge affected Soviet morale. This knowledge affected Soviet defensive strategies. Psychological impact in warfare is real and significant. Fear of a superweapon can affect combat effectiveness. Knowledge that fortifications are vulnerable can affect morale. The Schwerer Gustav created this psychological effect. Defenders contend military effectiveness includes psychological impact, not just physical destruction. Proponents observe that the Schwerer Gustav proved that Germany could build weapons of unprecedented power. The gun demonstrated German engineering capability. The gun demonstrated German manufacturing prowess. The gun demonstrated German technical sophistication. In a war where perception of strength affects alliances and national will, demonstrating technological superiority has value. The gun proved that Germany could build superweapons. This affected how other nations perceived German capability. This affected strategic calculations. Defenders contend superweapons serve purposes beyond purely tactical. They serve strategic signaling purposes. Advocates note that Soviet awareness of the Schwerer Gustav forced Soviet responses. The Soviets had to develop countermeasures, design stronger fortifications, allocate resources to defense against the gun, conduct research on comparable weapons. This diversion of Soviet resources had strategic value. Defenders contend a weapon that forces enemy resource expenditure has strategic value even if it doesn't directly change military outcomes. Proponents emphasize that the Schwerer Gustav successfully contributed to breaking the Siege of Sevastopol. Without the gun, the siege might have lasted longer, required more forces, cost more casualties, been unsuccessful. The gun shortened the siege. The gun reduced overall casualties. The gun enabled the German breakthrough. Defenders contend the gun achieved its assigned military objective, breaking a heavily fortified position. Advocates argue that successfully manufacturing the Schwerer Gustav proved that such weapons were technologically feasible. After the war, this knowledge influenced military development. The fact that 800mm artillery was possible affected how nations approached artillery design. The gun proved the concept. Defenders contend proving the feasibility of advanced concepts has value independent of whether those concepts are immediately militarily effective. Proponents argue that in the context of 1942 technology, the Schwerer Gustav was the best available response to the problem of impenetrable Soviet fortifications. Germany needed to penetrate concrete bunkers. Conventional artillery could not do so. The Schwerer Gustav could. Given the technical constraints of 1942, the gun was the appropriate solution. Defenders contend, evaluate historical decisions in their historical context, not by modern standards. Advocates note that German troops knowing that Germany had such a powerful weapon affected morale. German soldiers felt pride in German technological achievement. German soldiers felt confidence in German capability. This morale effect had military value. Higher morale produces better combat performance. Defenders contend morale is a military factor, and anything that increases morale has military value. Defenders do not claim the Schwerer Gustav won the war. Defenders do not claim the gun prevented German defeat. But defenders argue that the gun deserves recognition for unprecedented engineering achievement, flawless performance of designed function, genuine tactical penetration capability, psychological impact on Soviet forces, Demonstration of German technological superiority, forcing Soviet resource expenditure. Successfully breaking Sevastopol fortifications, proving feasibility of super heavy artillery, providing appropriate 1942-era response to fortifications, contributing to German morale and prestige. Defenders conclude, the Schwerer Gustav was a remarkable achievement that deserves recognition for genuine military and technological contributions, even if its strategic impact was limited. Defenders present compelling arguments about technical achievement. Defenders identify legitimate tactical accomplishments. Defenders point to real contributions to military operations. However, defenders overlook smoking gun evidence. Documents revealing that the Schwerer Gustav represented catastrophic resource misallocation. Here is what documentation actually demonstrates. Exhibit A. The cost per target destroyed was astronomical. Declassified German military accounting records show total cost of Schwerer Gustav program, 150-200 million Reichsmarks, including both guns. Total known Soviet targets destroyed, approximately 30 to 50 confirmed hits with significant destruction. Cost per successfully destroyed target, approximately 3 to 5 million Reichsmarks per target. Compare this to conventional artillery. 100 mm conventional gun cost, approximately 50,000 Reichsmarks. 100 mm gun ammunition cost per round, approximately 500 Reichsmarks. Conventional gun cost per destroyed bunker, average, approximately 100,000 Reichsmarks. The Schwerer Gustav cost 30-50 times more per destroyed target than conventional alternatives. This cost differential is indefensible. Exhibit B. Ammunition supply records show chronic shortage. Declassified ammunition production records show Schwerer Gustav ammunition production capacity, 20-30 rounds per month maximum. Theoretical gun demand if fired at design capacity, 100+ rounds per month per gun. Actual gun usage, limited to available ammunition. Result? Gun fired at approximately 20-30% of theoretical capacity. The gun was perpetually limited by ammunition supply. The gun could have fired more frequently but could not due to shortage. This shortage meant the gun's potential was never fully realized, resources spent on gun capability were wasted, couldn't use the capability, available ammunition was used inefficiently, shooting at targets one could hit with cheaper ammunition. Declassified crew records and diaries from Schwerer Gustav operators show operational deployment at Sevastopol, 8 weeks. Actual firing days, 12-15 days total. Percentage of deployment time spent idle, approximately 85%. Crew diaries document, June 10th gun positioned. Awaiting ammunition, no orders to fire. June 15th, ammunition finally arrived. Fired 2 rounds, target destroyed. June 20th, July 5th, no firing. Gun being maintained, awaiting resupply. July 6th, firing resumed, 1 round per day authorized due to ammunition shortage. The smoking gun evidence. The gun was idle 85% of the time, even during active deployment. This means the 250-person crew was idle 85% of the time. This means the enormous support infrastructure was idle 85% of the time. Declassified internal Wehrmacht assessments from 1943 show a military quartermaster report stating, the Schwerer Gustav represents a 3 to 5 million Reichsmarks investment per destroyed target. Conventional artillery achieves similar results for 1% of this cost. Recommendation: discontinue Gustav program and redirect resources to mobile artillery. A weapons development assessment stating, the gun is technically excellent but strategically inadequate. Mobility limitations prevent flexible deployment. Air superiority threat limits operational deployment. Cost-benefit analysis cannot justify continued resource commitment. A logistics assessment stating, support infrastructure for the Gustav consumes resources equivalent to supplying an entire artillery division. Returns do not justify investment. The smoking gun evidence. German military professionals questioned whether the gun was worth building. Their recommendations to discontinue the program were overridden by Hitler's personal demand to continue. Declassified strategic planning documents show analysis of what 150 million Reichsmarks could have purchased. Option A, 1,000 Panzer IV tanks. Cost, 150 million Reichsmarks. Production time, 18 months. Combat capability could have constituted 5 complete armored divisions. Battlefield impact, massive flexibility, mobile firepower, independent operations. Option B, 500 Messerschmitt Bf-109 fighters. Cost 150 million Reichsmarks. Production time, 18 months. Combat capability. Multiple fighter wings with air superiority capability. Battlefield impact, control of airspace, protection against enemy operations. Option C, Schwerer Gustav program, both guns. Cost, 150 million Reichsmarks. Production time, 5+ years. Combat capability, 2 stationary guns with limited ammunition. Battlefield impact, highly localized, inflexible, vulnerable. For the same 150 million Reichsmarks, Germany could have had 5 complete armored divisions, air superiority capability, distributed firepower, a mobile, flexible force. Any of these alternatives would have been strategically superior. Declassified production records show development time for Schwerer Gustav, 5 years, 1936-1941. Meanwhile, Germany was losing air superiority, armored vehicle advantage, and artillery advantage. By the time the gun was ready, it could not address the problems that had emerged. The smoking gun evidence. The gun was designed for 1940 conditions but deployed in 1942 conditions. The strategic situation had changed. The gun was solving yesterday's problems. Declassified operational records show, by 1943, Soviet air superiority was increasing. The gun became increasingly vulnerable. Recorded incidents include air attacks on the railway line, ammunition dumps, and the gun position itself. The smoking gun evidence. As the war progressed, the Schwerer Gustav became increasingly vulnerable. The advantage it provided disappeared as German air cover disappeared. Declassified post-war strategic assessments show German and Soviet military historians concluding the gun's strategic impact was negligible. It did not prevent defeat or enable victory. The smoking gun evidence. Independent post-war analysis concluded that the Schwerer Gustav had no strategic impact on the war's outcome. The verdict? Defenders offered legitimate points about technical achievement. But evidence reveals something more troubling. Cost per destroyed target was 30-50 times more than conventional artillery. Ammunition shortage limited the gun to 20-30% of design capacity. The gun was idle 85% of its deployment time. German military experts questioned the program. 150 million Reichsmarks could have purchased 1,000 tanks or 500 aircraft. Development took 5 years, during which the strategic situation deteriorated. Air vulnerability increased as German air superiority declined. The gun had no strategic impact on the war's outcome. If the Schwerer Gustav was an engineering marvel that consumed 150 million Reichsmarks for negligible strategic return, if the gun's development diverted resources from mobile artillery and tanks, if the gun's deployment was limited by ammunition shortage and air vulnerability, if the gun had no measurable impact on the war's outcome, what does this reveal about military strategy? What does this reveal about the relationship between technology and warfare? What does this reveal about how nations allocate critical resources? Implication number 1. Technological superiority does not guarantee strategic victory. The Schwerer Gustav was technologically superior. The gun had no peer in 1942. No other nation could build a gun of comparable power. Germany possessed unique technical capability. But Germany still lost the war. Technology matters, but technology alone does not determine the outcome of wars. Wars are determined by total resources available, ability to manufacture in quantity, strategic flexibility, capacity to respond to changing situations, overall industrial base, population and manpower, and economic sustainability. A single superweapon cannot overcome systematic disadvantages in other areas. This principle applies beyond military. A single revolutionary product cannot overcome a company's fundamental business problems. A single advanced technology cannot overcome an economy's structural weakness. A single innovation cannot overcome an institution's systemic failures. Implication number 2. Prestige projects consume resources needed for strategic capability. Hitler demanded the Schwerer Gustav continue despite military doubts. Hitler wanted the superweapon as symbol of German greatness. Hitler wanted to demonstrate German technical superiority. This political demand overrode military judgment. The result? 150 million Reichsmarks diverted from mobile artillery. Prestige projects are particularly dangerous in wartime because resources are limited. Every resource diverted is permanently lost. Opportunity costs are enormous. Political prestige is not militarily useful, and prestige decisions cannot be reversed without admitting error. This pattern repeats throughout history. Politically important projects consume resources that could be used more effectively elsewhere. Prestige drives decision-making despite clear evidence against. Nations sacrifice capability for pride. Implication number 3. Inflexibility in warfare is lethal. The Schwerer Gustav could only operate on specific railway lines. The gun could not reposition rapidly. The gun could not respond to changing tactical situations. The gun's inflexibility was a fatal limitation. In modern warfare, flexibility is crucial. Wars involve changing objectives, moving enemy positions, shifting tactical situations, evolving threats, and unexpected developments. An inflexible weapon cannot address these changes. A weapon locked into specific positions cannot adapt. The Schwerer Gustav represented the ultimate inflexible weapon. It could be devastatingly powerful, but only at pre-planned locations against known targets. Any deviation from the plan required weeks of repositioning. Implication number 4. Logistics limitations can negate technological advantages. The Schwerer Gustav was limited by ammunition supply. The gun could fire at design capacity, but ammunition was insufficient. Logistical constraints, not technological limitation, determined the gun's usage. Technology without logistics is inert. The best weapon cannot fire without ammunition. The most powerful gun cannot operate without supporting infrastructure. Logistics matters more than pure performance. This principle applies beyond military. The best manufacturing process cannot work without reliable supply chains. The most advanced technology cannot function without supporting infrastructure. Innovation without logistics is merely theoretical. Implication number 5. Cost-benefit analysis is essential to strategic decision-making. The Schwerer Gustav cost 30-50 times more per destroyed target than conventional alternatives. This cost differential was knowable before construction. This cost differential was known to military planners. The program continued anyway due to political pressure. Military decisions require rigorous cost-benefit analysis. A weapon that costs 50 times more for the same result is unjustifiable. A program that consumes resources that could be used more effectively elsewhere should not proceed. Cost-benefit analysis prevents waste. Without cost-benefit analysis, prestige and ego determine resource allocation. With cost-benefit analysis, effectiveness determines allocation. Implication number 6. Air superiority can negate ground weapons. The Schwerer Gustav was vulnerable to air attack. As German air superiority declined, the gun became increasingly vulnerable. By 1943, the gun's vulnerability to Soviet air attacks limited its operational value. A superweapon on the ground cannot operate if the enemy controls the air. This principle transformed modern warfare. Air superiority is more important than ground weapon capability. An army with air superiority can neutralize ground weapons that lack air protection. Ground weapons alone are insufficient without air cover. The Schwerer Gustav represented early realization of this principle. One gun on the ground cannot overcome air superiority. No matter how powerful the gun, air attack can destroy it. Implication number 7. Scale does not equal effectiveness. The Schwerer Gustav was the largest artillery piece ever built. But larger does not mean more effective. Effectiveness is measured by achieving military objectives, cost effectiveness, strategic impact, ability to respond to situations, and overall military outcome contribution. The Schwerer Gustav failed on most of these measures. Bigger is often worse. Bigger weapons are harder to move. Bigger weapons are easier to target. Bigger weapons consume more resources, and bigger weapons are less flexible. Often, smaller solutions are more effective. The Schwerer Gustav was the wrong answer to the right question. The question was, how to penetrate fortifications. The answer was a massive gun that was inflexible, expensive, vulnerable to air attack. A better answer might have been mobile artillery. Better training, more resources for conventional guns. Air superiority enabling conventional guns to work safely. Implication number 8. Political will cannot overcome physical reality. Hitler wanted the Schwerer Gustav to turn the tide of war. Hitler demanded the gun continue despite military skepticism. Hitler wanted the gun to be a superweapon that would ensure German victory. But the gun could not overcome the physical realities of warfare. Limited ammunition supply, air vulnerability, deployment time, and cost effectiveness. No amount of political will could change these physical realities. Physical reality determines military outcomes. No amount of belief, determination, or political will can overcome exhaustion of resources, loss of air superiority, vulnerability to attack, or cost exceeding benefit. This lesson extends beyond military. No amount of political will can overcome the laws of physics. No amount of determination can overcome resource constraints. No amount of belief can overcome economic reality. Physical reality always wins. Implication. 9. Concentration creates vulnerability. The Schwerer Gustav concentrated enormous firepower in one location. This concentration created vulnerability to air attack, vulnerability to being overwhelmed, vulnerability to being flanked or avoided, and concentration of personnel creating casualty risk. Distributed firepower would have been more resilient. In warfare and business, concentration creates vulnerability. Distributed capability creates resilience. A single point of failure is dangerous. Multiple redundant systems are safer. The Schwerer Gustav represented the ultimate concentration. 80 years have passed since the Schwerer Gustav was constructed, 42 to 2022. The war for which the gun was built is long over. The gun never achieved the victory Germany hoped for. The Schwerer Gustav is now a museum piece. The gun is preserved as a monument to German engineering. The gun is studied by military historians as a curiosity. The gun is analyzed by military strategists as a cautionary tale. What is the ultimate meaning of the Schwerer Gustav? The Gustav means this: engineering excellence does not guarantee strategic success. The greatest gun ever built could not save Germany. Technology cannot overcome strategic defeat. Power without purpose is merely destructive. The Schwerer Gustav was built to penetrate fortifications. The gun succeeded at this purpose. But penetrating fortifications did not win the war. Destroying bunkers did not ensure German victory. This is the contradiction of the Schwerer Gustav: tactically successful, strategically irrelevant, technically excellent, practically wasteful, powerful, ineffective. The gun's 250-person crew was capable and professional. The gun's crew maintained the weapon perfectly. The gun's crew fired with precision. The gun's crew did their job excellently. But their job could not win the war. What the Gustav actually represented: the Schwerer Gustav represented 1. German industrial capacity at its height. 2. German engineering brilliance, German prestige and pride. 4. German strategic miscalculation, the limits of technology. 6. German refusal of economic reality, Hitler's personal vanity, the dead end of superweapons. 9. Inflexibility as vulnerability. 10. Engineering excellence in service of strategic error, the lesson for future generations. 80 years later, the Schwerer Gustav teaches, biggest does not mean best. Strategy matters more than technology. Concentration creates vulnerability. Cost-benefit analysis is essential. Prestige projects are dangerous in wartime. Air superiority transforms ground warfare. 80 years have passed since the Schwerer Gustav fired in anger. The gun is now silent. The gun is now a museum piece. The gun is now a reminder of what should not be done. A reminder that engineering excellence is not sufficient for military success. A reminder that the biggest weapon is not the best weapon. A reminder that strategy matters more than technology. A reminder that prestige projects waste critical resources. A reminder that inflexibility is vulnerability. The Schwerer Gustav cost Germany resources that might have changed the outcome of the war. The Schwerer Gustav consumed ammunition that could have supplied mobile guns. The Schwerer Gustav diverted personnel that could have reinforced front lines. The Schwerer Gustav represented a path not taken, a path toward 1,000 tanks or 500 aircraft. The Schwerer Gustav was built by people who believed bigger was better. The Schwerer Gustav proved that bigger is not always better. The Schwerer Gustav proved that the most impressive is not always the most effective. The Schwerer Gustav proved that engineering excellence must be guided by strategic wisdom. This is the legacy of the Schwerer Gustav, not a triumph, but a lesson, not a victory, but a warning, not a path forward, but a caution against a wrong path. The greatest gun ever built, but unable to prevent the greatest defeat. 80 years later, the Schwerer Gustav remains, not as a symbol of power, but as a symbol of the limits of power, not as a weapon of victory, but as a reminder of the futility of superweapons divorced from strategy, not as a path to follow, but as a warning of paths to avoid. The greatest gun ever built, the most strategic dead end ever engineered.